The 1918 Nobel Prize for Chemistry is probably the most important Nobel Prize ever awarded. It was given to German scientist Fritz Haber, the genius who cracked a worldwide puzzle that had baffled scientists for ages. Using his innovative Haber-Bosch process, he transformed the production of fertilizer, a solution still in use today. Fritz Haber's development of the Haber-Bosch process marked a massive turning point in agriculture history. This breakthrough enabled the large-scale synthesis of ammonia, a key component in synthetic fertilizer. Why is Fritz Haber and his invention a turning point in history? Food supplies were so bad that in 1856, bird poop was once a hot commodity at $76 per pound. Why was bird poop such in high demand, you're wondering? Simple. Bird poop or guano is packed with 20% nitrogen, the secret sauce for robust plant growth. Although Fritz Haber discovered nitrogen is not rare, it's common. Actually, 78% of the air we are surrounded by is nitrogen, but it's in a form where plants cannot use. Fritz Haber decided to join in on this problem in 1904. As a 36-year-old working as a low-level academic at the University of Karlsruhe, he tried solving countless methods, but it seemed like he was joining the group of failed chemists. His most significant contribution came in the form of creating ammonia by circulating nitrogen and hydrogen. At high pressure and high temperature, in the presence of a catalyst, something that lowers the amount of energy required to split the atomic nitrogen. To do this process, he had to invent new equipment in order to do this process, building equipment that could even withstand even higher temperatures and pressures. At the time he was constructing this, he was a technical consultant for a light bulb manufacturer. That meant that he had easy access to lots of really hard to find materials back in the 1900s, like the element osmium, which is super rare. Since the light bulb company was using osmium for the light bulbs experiment, Haber thought it would be the perfect catalyst to bring back to his lab. And then, in the third week of March 1909, he put osmium in the pressure chamber. Then Haber pressurized and heated the nitrogen and hydrogen to 200 atmospheres and 500 degrees Celsius. And in Fahrenheit, that's 932 degrees. Then the most important reaction occurred. The triple bonds broke apart, and nitrogen reacted with hydrogen on the total gas mixture. 6% turned into ammonia. When the gas began to cool, 1 millimeter of ammonia dripped out the end of a narrow tube into a beaker. Later on, Germany's biggest chemical company, BASF, commercialized Haber's process within 4 years. They had opened a factory in Oppau, producing 10,000 pounds of ammonia per day. From mass production of ammonia from this industrial process turned into synthetic fertilizers, farmers were able to grow 4 times as much food with the same amount of acres of land they had originally. And as a result, the population of the earth quadrupled. Now the earth supports 4 billion more people than it could without the nitrogen fertilizer. The process is so important that around 50% of the nitrogen atoms in our bodies came from the Haber process. Haber became wealthy from the invention and got promotions to become the founding director of the Kaiser Wilhelm Institute for Physical Chemistry in Berlin. While he was working in the institute, he made friends with other scientists, probably the best scientists everyone knows to today. These scientist friends included Max Planck, Max Born, and even Albert Einstein. He was surrounded by good scientists and good friends. They were such good friends that when Einstein separated from his first wife in 1914, he stayed the night at Haber's house. But why was Haber so avoided? persistently being ignored by his friends when he was awarded the Blue Nobel Prize. Well, it all comes down to what happened when he kept researching about ammonium nitrate's other usages. When World War One broke out, Haber volunteered for military duty. He was passionate about the fatherland and wanted to use his chemistry abilities to help his country win the Great War. Haber discovered ammonium nitrate. Instead of creating fertilizer, it can be used as explosives. How dangerous was ammonium nitrate? Well, take a look at what happened in Beirut, August of 2020. That explosion contained 3,000 tons of ammonium nitrate that got caught on fire. Since it was on fire, the extreme heat made the fertilizer react and explode. The blast was heard many miles away and killed 217 people and injured thousands of people. The same thing happened to the Alpau plant where Haber's process was first put into practice, which would also explode in 1921. Why does ammonium nitrate explode? Well, the reason is because it's nitrogen. Whenever two nitrogen atoms come together, a huge amount of energy is released. The explosions of TNT, gunpowder, and ammonium nitrate all create a diatomic nitrogen gas. Because of the formation of the triple bond, it's where the explosion energy comes from. Haber wanted all factories to start making explosives. Later on, he wanted to make toxic gas, something heavier than air, to sink into enemy trenches. He was so invested in toxic gas, he converted his wing of the institute into a chemical weapons laboratory. Few months of work in the lab, he created chlorine gas. An employee, Otto Hahn, expressing his negative emotions on Haber's new weapon, Fritz Haber said, "Innumerable human lives would be saved if the war could be ended more quickly in this way." At 6 p.m. on the 22nd of April, with the wind blowing toward the Allied trenches, German troops released 168 tons of chlorine from over 5,000 gas cylinders. It sank over the Allied trenches. 5,000 Allied soldiers died on the first attack on gas. A week later, Fritz Haber was promoted captain. He came home to Berlin. The Habers threw a party for his promotion. Haber took sleeping pills, then went to bed. That same night, Haber's wife took Haber's service gun, went outside, and shot herself, showing he used his skills for harm rather than for good. Fritz Haber's daughter, Eva Lewis, said, "I think originally, probably science was more important than Germany. But once you come to the first World War One period, I think then it became Germany. How do you defeat your enemies? What can you think of? What can you contribute? You as a scientist, what's your contribution going to be?" Fritz Haber later moved to the Western Front and planned his next gas attacks when his wife committed suicide. Later on, Germany surrendered. Haber was crushed and all the money he made from the ammonia patent was lost due to hyperinflation. In 1933, the Nazis passed a law that all Jewish civil servants, including scientists, were to be fired from their jobs. The institute Haber was working for fired all Jewish scientists. Haber was Jewish, but he never practiced the religion. But because of his contribution to the war, he was exempt from the law, but he resigned. Eva Lewis said he had a letter to say that he, Fritz Haber, could stay, but the Jewish collaborators and assistants would have to go. So Fritz Haber answered this letter and said, "In that case, you have my resignation." A year later, in 1934, in a hotel room in Basel, Switzerland, he died of a heart failure.